I want you to pause for a second and think about every transaction you made this week. Every bank transfer, every online order, every work message, every one of those moved through a cable that has less physical protection than the water pipe under your street. And there are fewer than 60 ships on the entire planet capable of fixing one if it breaks. Right now, as you watch this video, your data is racing through a strand of glass fiber buried under 3 miles of freezing ocean at nearly the speed of light. Not through satellites, not through the cloud, through glass, on the ocean floor, unguarded. There are 559 active submarine cables stretched across the ocean floors right now. Combined, they run 1.4 million kilometers, enough to wrap around the Earth 35 times. They carry 95% of everything on the internet. Every military communication, every financial transaction, every streaming service, every government data transfer on the planet. Satellites handle less than 1%. The cloud is not floating above you. It is lying silently at the bottom of the ocean. And what we are about to show you is how fragile that really is. But before we get into the failures, the sabotage, and the geopolitical war being fought 6 kilometers underwater, we need to answer a question most people never think to ask. Who actually owns all of this? For most of the internet's existence, undersea cables were shared infrastructure. Telecom consortiums, governments, distributed across many hands, many countries, many interests. That era is completely over. Amazon, Google, Meta, Microsoft. These 4 companies now control roughly half of all undersea bandwidth on the planet. Google alone is the sole owner of more than 10 submarine cable systems. As of 2024, content providers like these own 59 international submarine cables, up from just 20 in 2017. $11 billion in new cable construction is planned between 2024 and 2026. And the majority of that money is coming from Silicon Valley, not from governments. Think about what that means. The physical foundation of the global internet, the infrastructure that moves your data, your money, your medical records, your country's military communications, is increasingly owned by a handful of private corporations answerable to shareholders. And here's where it gets interesting, because the moment you understand who owns it, the next question becomes terrifyingly obvious. How easy is it to destroy? To answer that, we need to go back, way back, to 1858, and a dream that nearly killed the men who built it. Queen Victoria and U.S. President James Buchanan exchanged messages on August 16, 1858, the first words ever sent across the Atlantic Ocean through an undersea cable. The Queen's 98-word greeting took almost 16 hours to transmit through 3,200 kilometers of copper wire that 2 ships had dragged across an ocean floor no human being had ever seen. The world celebrated like the impossible had just happened, because it basically had. And then, a few weeks later, the cable went dead. An engineer had pumped 2,000 volts through a wire that couldn't handle it, burned it out from the inside. It took 8 more years before a reliable transatlantic cable finally worked in 1866. Here's the part that should unsettle you. The cables carrying your data today are laid in almost exactly the same way as those first Victorian wires. The ambition scaled. The fundamental vulnerability never really changed. So what does a modern cable actually look? Because most people imagine something massive, something armored, something worthy of carrying the world's entire digital civilization. The reality is almost insulting. At the core of a modern undersea fiber optic cable are hair-thin strands of ultra-pure glass fiber. Each one carries terabits of data per second using pulses of laser light. Surrounding the fiber is steel wire armoring, copper power conductors to feed the signal amplifiers spaced every 60 to 100 kilometers along the route, and layers of waterproof polyethylene sheathing. In the deep ocean, the entire cable is barely wider than a human wrist. A single cable system costs between $300 million and $500 million to build and deploy. Some corridors have cables sitting at depths of 11,000 meters, deeper than Mount Everest is tall, and once it's on the ocean floor, it is essentially unguarded. Which brings us to the part of this story that nobody in the industry likes to talk about publicly, because you might assume the greatest threat to this infrastructure is state-sponsored sabotage, military submarines, cyber warfare. And those threats are very real. We'll get to them. But the number one cause of cable damage on this planet is a fishing boat. Between 100 and 200 undersea cables are damaged every year. Most of those incidents are fishing trawlers dragging nets across the seabed, cargo ships dropping anchors in the wrong place, pure accidental human carelessness. Research consistently shows that the vast majority of cuts happen in shallow water, between 0 and 100 meters depth, because that's where ships operate and where anchors reach. There's even a documented history of sharks biting cables, attracted by the electromagnetic fields from the power conductors running through them. Modern armoring has largely solved that particular problem. But the fishing boats? That problem is very much unsolved. And here's what makes it worse. When a cable breaks under 3 miles of ocean, you can't send a diver. You need one of the most specialized vessels on Earth, a cable repair ship. A ship that can locate the break using sonar, deploy remotely operated vehicles to the seabed, grapple the cable back to the surface, splice it, and lower it back down without damaging it further. This process takes weeks, sometimes months. And as of right now, there are fewer than 60 of these ships in operation globally. Most of them are focused on laying new cables, not repairing old ones. During the catastrophic West African cable outages of March 2024, the Leon Thevenin, a single cable repair ship docked in Cape Town, was the only vessel dedicated to serving the repair needs of the entire continent of Africa. One ship, one continent, tens of millions of people waiting in the dark. 2024 was not an anomaly, it was a preview. In February of that year, 4 cables, the AAE-1, CCOM, EIG, and TGN systems, were severed in the Red Sea near Yemen. That single event disrupted internet services for more than 100 million people across West and North Africa, and knocked out 70% of data traffic between Europe and Asia. Then in March, 10 African countries lost connectivity due to 4 more cable breaks. Nigeria alone lost over $590 million in just 4 days. Then in November, 2 cables in the Baltic Sea went down. A 1,170-kilometer cable between Finland and Germany was severed. A 218-kilometer connection between Lithuania and the Swedish island of Gotland stopped working. 1 year, multiple continents, hundreds of millions of people cut off. And investigators still haven't definitively answered who or what caused all of it. But there are suspects, and one of them has been quietly operating 6 kilometers underwater for years. While NATO was drafting policy papers and holding summits about undersea infrastructure, Russia was already on the ocean floor. An organization called the Main Directorate of Deep Sea Research, known by its Russian acronym GUGI, operates deep-diving nuclear submarines, and a survey ship equipped with a submersible capable of reaching 6,000 meters depth. That puts virtually every undersea cable on Earth within its reach. The Russian Navy also operates survey vessels that in documented expeditions have deployed proton magnetometers, tools specifically designed to locate metallic objects on the seabed, objects like pipelines and cables. Since 2022, NATO and Western intelligence agencies have been urgently reassessing the risk Russia poses to underwater infrastructure. Working groups have been formed. Alternate cable routes are being discussed. But the capability already exists. It has existed for years, and it is sitting quietly at the bottom of the ocean right now. Russia is not the only geopolitical actor in this story. Every cable repair in the South China Sea, one of the world's most strategically critical waterways, requires Chinese government permits to enter territorial waters. Where that permit process once took around 10 days, industry insiders now report it takes closer to 4 months. Vietnam's undersea cables all went down in early 2023, and it took nearly 8 months to restore them, largely because of permit delays tied to China. U.S. officials have raised alarm about Chinese firm involvement in global cable projects, warning that China could potentially monitor data running through cables it helps build, or use permit bureaucracy as a silent weapon, leaving damaged cables unrepaired for months during periods of strategic tension. The ocean floor has become the new front line of the US and China technology war, and most people have no idea it's even happening beneath them. What makes all of this more dangerous is geography. Not all ocean is equally vulnerable. Certain choke points concentrate dozens of cables into tight corridors, meaning a single, deliberate attack could damage multiple networks simultaneously. The Red Sea, the South China Sea, the Taiwan Strait, through which cables connecting Japan, South Korea, and Taiwan to the global internet are threaded. The Luzon Strait, the Strait of Malacca. At cable landing stations, the points where undersea cables come ashore and connect to land-based networks, dozens of cables sometimes converge in a single physical location. These stations supply power to the cables and serve as the gateway between ocean and internet. And their locations were historically chosen for practical reasons like existing infrastructure access, not for their defensibility against physical attack or natural disaster. The U.S. Department of Homeland Security noted in December 2024 that while incidents at geographic choke points are relatively rare, each one reveals just how catastrophic concentrated cable damage could be. So what is actually being done? In 2023, NATO established a maritime center for the security of critical undersea infrastructure in the United Kingdom. In January 2025, NATO launched a mission called Baltic Sentry, specifically to protect undersea infrastructure in the Baltic Sea. The Quad Partnership, the United States, Japan, Australia, and India, launched a partnership for cable connectivity and resilience in 2023 to support vulnerable island nations. New fiber optic sensing technology is being deployed that can detect vibrations, pressure changes, and physical disturbances along cable routes. Uncrewed underwater vehicles are being explored as patrol systems for shallow cable corridors. $11 billion in new cable construction is planned over the next 2 years, with routes being deliberately designed to bypass the most dangerous choke points. These are real steps. But critics, and there are many, point out that for a network carrying $9 trillion in daily financial transactions, the response remains fragmented across dozens of national jurisdictions, underfunded relative to the threat, and years behind the capabilities of the actors it's trying to deter. Africa has already lived through what the rest of the world is trying to prevent. 10 countries going dark simultaneously, a single repair ship for an entire continent, $590 million lost in 4 days in one country alone. Regions with low redundancy, parts of West and Central Africa, isolated Pacific islands, secondary European routes, are structurally more exposed than anywhere else on Earth. When the cables break, and the one available ship is already occupied, those countries simply have to wait. Africa's crisis is not a regional problem. It is the clearest possible demonstration of what happens when critical infrastructure has no redundancy, no repair capacity, and no geopolitical protection. It is a warning that most of the world has not fully absorbed. The next major disruption is not a matter of if. Engineers know it. Intelligence analysts know it. NATO officials have said it publicly. The only question is whether it will be an accident, a natural disaster, or the opening move of something far more deliberate. And here is the uncomfortable truth at the center of all of this. The global internet was never designed with security in mind. It was built for speed, for capacity, for cost efficiency, cable by cable, decade by decade, across 160 years, without a unified plan, without centralized protection, without a global authority capable of responding when things go wrong. Now the world is trying to retrofit geopolitical armor onto infrastructure that was never built to need it. $11 billion is being spent, new routes are being drawn, drones are being deployed, summits are being held, and somewhere right now, a fishing captain is dragging an anchor across a seabed he has never heard of, directly toward a fiber optic cable carrying billions of dollars of transactions per second. The internet is not in the cloud. It is 3 miles underwater. It is a strand of glass. It is barely wider than your wrist. And it is holding on barely.